Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Haikal bin Abdul Rahim, CN220358. Today, we want to talk about Group 14 project, the case study in people's sleeping pattern. The writers in our group is first Maisara binti Maliki, AN220011, Nur Juliana Aisyah binti Johar, AN220049, Siti Nonatra binti Jusuf, AN220218, Muhammad Nazran bin Abdul Asni, CN220368, and me, Muhammad Haikal bin Abdul Rahim, CN220358. This is overview of our case study, introduction, case study, methodology, random variables, spatial probability distribution, sampling distribution, estimation, hypothesis testing, simple linear regression, conclusion, and discussion. Introduction. What is statistics? Statistics is the science concerned with developing and studying methods for collecting, analyzing, interpreting, and presenting numerical data. Statistics is a highly researched in the statistics field, individual or scientific field, and research question in the various scientific field motivate the development of new statistical method and theory. In developing method and studying the theory that underlies the method statistics of drawn on a variety of mathematical tools. Two fundamental ideas in the field of statistics are uncertainty and variation. There are many situations that we encounter in a science or more generally in life in which the outcome is uncertain.
Methodology for case study. The title of case study is sleeping pattern. A person schedule of bedtime and wake up time as well as nap behavior. Sleep pattern may also include time and duration of sleep interruptions. Sleep phase. The timing of a person's typical sleep period. From there, we collect the data of sleeping pattern. This data below take the average of people awake. Why we need this data for the sleeping pattern? Data collection is important in statistics since it gives the raw data needed for research, analysis, and decision making. It serves as the basis for creating meaningful insight, drawing conclusion, and making evidence-based decision for individuals, company, and organization. And here the results. Here the table that we use in the case study. The first column is number of people. Number two is age around the people that we use to find sleeping pattern. Number three is gender. Number four is sleeping duration. Number five is sleeping effection. Number six is REM sleepiness, and then deep sleepiness. Next is light sleepiness, and that's awakening. Uh, and then the caffeine, alcohol, smoking, and exercise frequency.
Next, for chapter 1, the issue on this case study is suppose X denotes the number of sleeping pattern by the student. From an examination of the working tabular the probability distribution function. Refer figure 1. The issue apply quantitative data, measure or counts according using number. Specifically use discrete random variable, a type of random variable that can take on a finite of countable number of distinct value. So we can see the awaking from 0, 0, 1, 0, 3, 1. And we transfer to figure 1, x 0, 1, 2, 3, 4, and px 0.3, 0.17, 0.13, 0.3, and 0.1. And next, the random variable chapter 1. The question is, suppose x denotes the number of sleeping patterns by the student. From the probability distribution function table above, find the cumulative distribution function of x. So the solution is p in bracket x less than 0 equal to 0. If x equal to 1, the value that we get is 0.47. If x equal to 3, the value that we get is 0.9. And if x equal to 4, the value that we get is 1.0.
Before proceed to the chapter 2, we need to know the mean and the variance. In the question, suppose X donate the number of sleep pattern by the student. From an examination of the awakening of 30 students, calculate the mean and variance. The solution. Mean EX equal to the summation XPX equal to 1.40. Number 2 is variant x equal to ex square minus ex in the bracket square. The solution is 2.83. In chapter 2, special probability distribution, the issue of this case study is one of the survey in Malaysia has average of 30 out of every 100 people. A random sample of 30 people sleeping pattern is selected. Find the probability that first, exactly 20 awakening, and then number 2, less than 25 awakening. The solution is x minus b in the bracket 30 0.3, px equal to 20, and the solution is 0.000296. And the number 2 is p in the bracket x is less than 25. The answer is 0.9997.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Maisara binti Maliki. My metric number is AN220011. I will be conducting the presentation on chapter 3, which is sampling distribution. For my case study, I use the sampling of the single mean distribution, which is in my case, the case study I chose is about a university randomly selects 30 students from its population and ask them about their average sleep duration on weekdays and is tabulated from the data below me. The population mean sleep duration is 7 hours with the standard deviation of 2.2 hours. And in this case study, we'll find the probability of average sleep duration greater than the sample mean. So first things first is in order to complete this question, we will have to find the info, which is the sample size being 30, the sample mean, which we have to find by using the formula of total of the sleep duration data over the sample size, and also the population mean, which is 7 hours and having the standard deviation of 2.2 hours. From here, we know that the formula of the sample mean being total data over 30, so we will get 227.5 over 30, and after the calculation we will have 7.58. Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Maisara binti Maliki. My metric number is AN220011. I will be conducting the presentation on chapter 3, which is sampling distribution. For my case study, I use the sampling of the single mean distribution, which is in my case, the case study I chose is about a university randomly selects 30 students from its population and ask them about their average sleep duration on weekdays and is tabulated from the data below me. The population mean sleep duration is 7 hours with the standard deviation of 2.2 hours. And in this case study, we'll find the probability of average sleep duration greater than the sample mean. So first things first is in order to complete this question, we will have to find the info, which is the sample size being 30, the sample mean, which we have to find by using the formula of total of the sleep duration data over the sample size, and also the population mean, which is 7 hours and having the standard deviation of 2.2 hours. From here, we know that the formula of the sample mean being total data over 30, so we will get 227.5 over 30, and after the calculation we will have 7.58.
Assalamualaikum, my name is Juliana Aisyah. Statistical inference is a method used to draw conclusion about a population from a sample. It involves estimating the characteristic of the wider population using data from 18 samples. Parameters of the population include mean, variance, and percentage. Estimate come in two flavor: point and interval. Point estimate are single estimate, while interval estimate have a level of confidence in the interval containment of the population parameter. In this chapter, contain 4 subtopics, which is large sample estimation of population mean, small sample estimation of a population mean. Next, large sample estimation of a population proportion, and estimation procedure for two population. For this chapter, the case study is a researcher want to investigate the average duration of sleep for students in university. They collect data from a random sample of 1,000 students and record their nightly sleep duration. The sample mean of sleep duration is found to be 7.5 hours with a standard deviation of 1.2 hours. Based on this information, the researcher want to estimate the population mean sleep duration for all students in the university. They also want to determine the margin of error for their estimate using a 95% confidence level. what is the estimated population mean sleep duration and what is the margin of error for the estimate. So the sample mean is 7.5 hours and the random sample is 1000. The standard deviation is 1.2 hours. So we got the percentage confidence level by 95%. For the percentage, we can apply the percentage in alpha formula, which is alpha equal to 1 minus 0.95. So we got 0.05. So we already got all the info. We can apply on this formula, which is sample mean plus minus z alpha over 2 multiplied by standard deviation over sample. We can find value of z by searching on the table 4, which is I get the value is 1.96, and then we can multiply like usual, and we can plus minus with the 7.5, and we got the margin of error is approximately plus minus 0.074 hours. This means we can be 95% confident that the true population mean sleep duration fall within the range of 7.4257 to 7.5743 hours.
Hi, my name is Natra. My metric number is AN220218. So today I'm gonna introducing to hypothesis testing. Okay, hypothesis testing is a methodical process for determining whether research study findings are consistent with a specific idea that pertain to a population. To evaluate a hypothesis about population, hypothesis testing use sample data. The major purpose of hypothesis testing is to choose between two competing hypotheses about the value of population parameters. Okay, for case study for my question is, the sleep harmony program is a new relaxation program introduced by a sleep clinic, claiming to increase the average nightly sleep duration to 8 hours. To validate this claim, a skeptical researcher decided to conduct a study on participants who undergo the program. The primary objective is to investigate whether the sleep harmony program has a significant impact on the average nightly sleep duration compared to the claimed target of 8 hours. From the question and given data, we know that sample size is equal to 30 and the alpha is 0.05. So how to get the sample mean is we use the formula for sample mean and total all the sleep duration over the sample size. To calculate the sample standard deviation, we need to find the mean, subtract the mean from each score, square each deviation, add the square deviation, divide the sum by the number of sample size, and take the square root for the result. 1. We need to find the null hypothesis and alternative hypothesis. So, which is null hypothesis is mean equal to 8 and alternative hypothesis mean is not equal to 8. Step 2, we need to give all the information about sample size, sample mean, sample standard deviation, alpha, and also the value of critical. From this information, we know that this is case C because the variance is unknown and sample size is bigger than 30. We need to refer the two tables Z distribution table to get the critical value. Alpha is divided by 2, so we got the value 0.025 and refer the table, so we got the critical value is equal to 1.95. For step 3, we need to input all the value into the formula to get the test value, which is sample mean subtract mean over sample standard deviation over square root sample size. Step 4, we need to define to use the decision either to reject or not reject the null hypothesis. If the test value is smaller than critical value, we need to not reject the null hypothesis, which is we need to use the null hypothesis to claim the skeptical. And step 5, if the decision is not reject, there is no enough evidence to support the claim that the average of sleep duration after the relaxation program is not.
So for the chapter 6, simple linear regression, the bedtime and wake up time futures indicated when each subject goes to bed and wake up each day, and the sleep duration future record the total amount of the time each subject sleep in hour. The sleeping efficient future is a measure of the proportion of time spent in bed that is actually spent asleep. The REM sleep percentage deep sleep percentage, and light sleep percentage. Feature indicates the amount of the time each subject spent in each stage of sleep. The working feature records the number of time each subject wake up during the night. Additionally, the dataset includes information about each subject, caffeine and alcohol consumption in 24 hours, prior of bedtime, the smoking status, and the exercise frequency. But in this datasheet, we only focus on the age that affect the sleep duration of the person. So we can see the age X from the lowest 11 years old and the highest is 69. And the sleep duration, the lowest we can see is 6 hours and the highest is 10 hours. So the solution, use the formula and the answer that we get from the table and include to the okay, to the formula, the answer that we get is the least square line is y equal to 8.1867 plus in bracket negative 0.0152 x. So that's all from me. Thank you. In conclusion, what I and my team learned first is in summary, statistics as a branch of mathematics involves the collection, inspection, and analysis of data, drawing conclusion through quantified model. And second, we learned in chapter 1 until chapter 6. In the chapter is widely applicable across various disciplines and fields, including theoretical and mathematical static, machine learning, data mining, and statistical computing. And lastly, that we learn from this project and this subject is statistics is important because it extends to everyday life, art, science, and environment study. So that's all from my team. Thank you.